Hello, everyone. This is Alice Fan, and I'm from Team Dvaraka. We'll be presenting our Dvaraka initiative. So, let me introduce you to my team members. We are the five members. We consist of 5 members, but only I'm here right now to present on behalf of my team. So, you must be thinking, what's Dvaraka? Dvaraka was a mythical colony which was lost in an Arabian Sea, city of many doors. It was considered to be the city of many doors, and it was considered to be the golden land of opportunities. Our Dvaraka, which will be made on Mars, will also be made on a lost sea of Mars, and it will open up many opportunities and new ventures for upcoming human race. The challenge statement for us was for first self-sustaining human Mars colony of 1,000 people. So our mission objective was to build first self-sustaining human colony of 1,000 people on Mars, to establish autonomy in the functioning of the colony, and to facilitate for profitable operation in the colony, to establish an ethical socio-political order in the colony. So this is our mission analysis timeline, which will be divided into 3 important phases: pre-initiative phase, settlement phase, and self-sustaining phase. So in 2024, the dawn of Dvaraka, the pre-initiative phase begins, where we'll be generation of initial investments, taking $5 billion over every 2 years. For 26 years, the total investment will be $65 billion. And from the training fees, we'll be generating investment of $315 billion for 1,200 trainees. So higher the investment, higher the people, more the number of representatives made. So, what's MATE? Martian Administrative on Earth. This will be consisting of 4 important departments: External Affairs, Finance, Mission Control Department, and Human Resource Department. Mission Control Officer will be the very important person, as he will be looking after the mission going onto Mars and coming from Mars. So we'll be spending about $3.2 billion on the operation of MATE, and $1.86 billion on the infrastructure of MATE. For the site selection, we have 3 important criteria. For the topography suitability, suitable for vegetation, in situ resource utilization. The first picture that you're seeing there is tells you all the best landing sites available on Mars surface. The dark blue gives you the best site, and the dark red gives you the worst sites. The just below picture gives you the global climate zones on Mars. Example, the blue area is your ice caps, the green area is your polar regions. So for manufacturing of our spacecrafts, we are spending upon $1.5 billion. Next, taking all the consideration with the criteria, we have narrowed down to Zero crater, which is located just western edge of Isidius Basin in Citrus Major. Right there, you can see a star. And its location is 18.4 degree north on 77.7 degree of east in Lily Fosse region. This crater is approximately 45 kilometers in diameter. So coming on 2026, we'll be down by $6.5 billion. Don't worry, we'll come up with the good numbers. So laying the foundation of Dvaraka. In 2026, we'll be beginning with 5 cargo missions carrying under-pressurized rovers, load-carrying trucks, nuclear generators, ISRU facilities. And for the mission, we are spending $1.2 billion. Along with the cargo missions, there will be a broadcasting event happening, which will be showing broadcasting the events of takeoff and landing, and in future, all the tourism and events happening on Mars. That will generate a revenue of $183 million. Let's prepare Dvarakans now for going on Mars. So we have a training program for 6 years. And space organizations will be having 1 year to have an application process and narrow it down to 250 candidates, which will go through a basic and advanced training, and after which they will go through an intense spacecraft flight training and Mars survival training. At the end of our 6 years of training program, only 200 candidates will be at the end. So in the early stage, these 200 candidates will be given an offer to join MATE so that they can understand Martian governance better. And for this, we'll be generating $1.2 billion. So coming on 2028 to 2034, which will be the building of Dvaraka. So in the beginning of this year, we'll be down by $12.9 billion. This year, we'll be having 4 more cargo missions, which is the previous 1 mission, and this is the other 4 missions, carrying all the major equipments. So all the 4 missions, the number that you see on the top corner is our expenditure on each mission. And during this phase, we are having a profit operations of $12.9 billion. So coming on 2036, the Dvaraka Genesis will begin, which will be down by $16 billion by that time. In 2036, we will be having our first manned mission landing taking off for Dvaraka, which will be consisting of 100 Dvarakans, food, spacesuit, and fertilizers. This mission will require $783 million. So coming on to the accommodation layout of Dvaraka, this is how the Dvaraka layout will look like. It will consist of 2 sectors. Each sector will consist of 5 blocks and an administrative block. The administrative block will consist of all the entertainment, and all the administrative work will be done over there. Adjacent to it will be the water, air, mineral processing facility, water extraction facility, fuel processing, and storage facilities. According to it, onto the other side, we will be having a landing site and cargo dock and nuclear generator reactors. We also have a tourism sector, and the important building is a mission control, who will be looking after all the smooth functioning of Dvaraka on Mars. This is the block layout. In every block, you can see we have 2 greenhouse, 1 lab, and a dining hall. The area that you can see on the edge of it is the living quarters, and the gray area that you can see is the passage for transport. This is the accommodation layout, how a room will look like in 10 by 2 meter. And we have designed it in such a way, in future, if somebody wants to be in a double, we can change this into a double-seater as well, instead of having single. So the material that we are using for the Dvaraka is sulfuric concrete sandwiched between regolith brick, and also having a thermomechanical coating. This thermomechanical coating is going to be a layered with many different materials, which will have a different function for pressure, insulation, and structure. So this will be somewhat 15 mm, and we have done a 2D and 3D analysis of our block, of our accommodation block. And we have come up with these values, which both almost approximately matches, which shows our during dust storm, our Dvaraka can withstand. So this layout shows all the process for producing water, fuel, and oxygen in Dvaraka. Approximately when the population reaches 60%, we will be having a Dvarakan Council set up on Mars. This Dvarakan Council will have 5 major departments: labor and commerce, education and agriculture, external affairs, colony development, defense and health, along with Earth representative who will not participate in taking any decision on Mars, but will rather be looking after the smooth functioning of Dvaraka. Here in defense, you can see at last is a smart card. Smart card will be the currency on Dvaraka, which is like a chip, which will consist of a points given. For 8 hours, you will be earning for 250 points, which is required, which will be enough for you to survive on Dvaraka. For which in this years, we are having positive operations of $366 million. In 2037, we'll put a breathing life into Dvaraka. By the beginning, we are down by $18 billion. Thermal design of the colony, in which we are using the nuclear generator. With the supply efficiency of 95%, we are generating 226.01 million BTU per day. That will be having some loss according to the colony infrastructure and other facilities. The electricity how the electricity will be produced in our colony. Our colony requirement is 6.1 megawatt, and for using the solar energy, we are generating 4.16 megawatt, and the remaining 3 we are taking out of 4.16. We are taking 3.1 megawatts, and the rest 3 we are getting it from the 30 nuclear generators. This is the case when there will be no dust storm. When during the dust storm, the excess energy that we are generating from solar energy will be saved in NIH batteries, and it will be supplied along with the nuclear generator. So at the end of every day, we will be having a colony requirement met. This is the layout of manure and water cycle plants. Potable waters will be provided to living quarters, kitchen and lab and greenhouse. The waste will be collected and will be going through 2 different treatment, urine treatment and your manure treatment. From urine treatment, we'll have the potable water extraction, and the nutrients that are being separated from there will be going to the decomposition site. And from decomposition site, the manures will again go back to the greenhouse for the plants. For breathable air circulation plant system, we are having air processing plant where breathable airs will be sent to living quarters, kitchen, lab, and the carbon dioxide from there will be sent to greenhouse. Greenhouse plants produces the purest form of oxygen, which will again go back to the air processing plant. So in 2037, we'll have a deuterium generation started, where deuterium on Mars is 833 parts per million. And this is used in first and second generation of fusion reactors. This, which will be sent on Earth, and it will generate a revenue of $746 million. By 2038 and 2042, we will be down by $17 billion. This will be starting the inhabiting of Dvaraka. So in every 2 years, the spacecrafts will be coming with 200 people. 2 flights will be coming with 200 people. And the corner amount that you can see is the investment on each mission. In this year, we are having $3.5 billion of positive operations. So by 2044 and 2049, the year where new ventures will be starting for Dvaraka, which will be, first is the asteroid mining. From Mars, we'll be traveling to the asteroid, extracting the materials with the efficiency of 75%, coming back on Mars, processing it and sending it on Earth, which will generate a revenue of about $5.8 billion. Mars, and next will be a Mars tourism, where depending upon the number of days staying and the propellant being used and the delta V that we require, we have 4 different schemes. The lesser the number of days, more the amount of fuel, so the costlier the ticket is. This entire tourism will generate a revenue of $62 billion. Towards the end, in 2044 and 2046, we will be having the last spacecrafts arriving with the Dvarakans. So in this year, we are having a positive operation of $4.7 billion. So by 2050, we bring it all together. We have now 1,000 people colony on Mars. And after paying off all the debt that we have, we still have $32 billion in our bank. We have also taken the worst case scenario. If in case any sector that goes rogue, we have 2 members from the Dvarakan Council in co-sign will cut off the smart card and the water supply. And if it still doesn't work and towards the intense situations, some percentage of oxygen supply will be cut down. So in the entire process, we have a profitable operation of $97 billion, and the investment we have is $65 billion. So we still have $32 billion with us to continue the process of making another. So this graph will show you the relative cumulative revenue. The red line that you can see is, as it shows, from 2024 to 2044, we don't have any positive revenue being generated. As soon as the tourism and asteroid mining kicks off, we have exponential increase in our revenue, which will reach to a point where we can pay off all our debts and enter into a self-sustainable phase. So this is a summary of my entire mission, which says about pre-initiative phase, your settlement phase, and your self-sustaining phase, including all the missions and the future. The future scope, the MAID will be turned into a Martian embassy. We'll have Mars can be a checkpoint for the future deep space exploration. There will be a technology science exchange between Earth and Mars, expanding of tourism, major science expedition between Earth and Mars, and if possible, we'll have another initiative, and we named it as Aryabhatta. I take a moment to thank all my sponsors, Space Master, Faculty of Electrical Engineering, Department of Control Engineering from Czech Technical University, our host university for this year for Space Master, Luleå University of Technology in Sweden, and University of Paul Sabatier, Toulouse, France, who all have been a great support for us. And also to the people who are not mentioned in the PPT, our all the team members, family members, and our friends. Thank you for their support, and also to the Mars Colony for giving us an amazing project to do, and it was a great time to work on it. And at the end, I would say the universe is not required to be in perfect harmony with human ambition.
Okay, questions for the presenter? Anybody have any questions?
Could you go back to the slide where you showed the candidates being winnowed down from 220 or whatever it was to 200? where they
Okay,
went
a
through the
training
various
program,
steps of training.
yes.
So when you get to, for instance, the basic training, are they doing both of those training? Each person's doing Mars science and physical, right?
Mars science and Mars science and other physical training, basic trainings. Basic training will be basic, like it's
Yeah, it's
to
not.
have
Really,
a
I'm just making sure. Under each of these categories, you're going to do both those things, right?
yes.
So when it comes to spaceflight training, you're going to send 206 people to the ISS.
I'm sorry, 200.
You're going to send 206 candidates to
Yes,
the International Space
yes.
Station. No, you're not.
No, not International Space Station. It's a spacecraft flight training on
okay.
Earth, not on ISS. That's impossible to send.
Any more questions? Yeah, one down here.
So you had a couple of unobtainiums here. One of them was fusion reactors. Be great if we had fusion reactors, but we don't.
Yes.
So, well, but, okay. The other one I wondered about was the asteroid mining. So why would you want to bring materials to Mars, put them down in the gravity well, to process them, to take them back up out of the gravity well, to take them to Earth?
We chose as asteroid mining because why we chose was asteroid belt is very close to Mars, and from Mars surface to take off is much easier and will require less fuel to take off. And now coming to the question why we are bringing it on Earth, because we are extracting the material from asteroid, and we have to process it in order to get the metals so that we can send it on Earth. Because if we send the raw material on Earth, the process time will again take for the none of the companies is going to buy it because they have to process it. But they all need is direct material which they can use it in the manufacture.
Okay, any other questions? If not, let's give a great round of appreciation to the presenter.